Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's lesson, I will explain you more challenging questions from kinematics. And this is third part. If you didn't see part 1 and part 2, go back to the channel and search for kinematic questions part 1 and part 2 because part 1 and part 2 are very helpful to have a super clear understanding of kinematics questions. Here is our first question. So let's try to answer this question now. So what we need to do, first of all, we have to read this question carefully. We need to understand what is given to us and what we need to find. So what is given to us? The first thing we need to find out what is given to us. So it is given to us in the absence of a resistance, a ball is thrown horizontally from a tower with velocity v, mean the initial horizontal velocity is v. And it took t seconds to land. Now, next is telling us if we consider a resistance, mean if we take a resistance into account, simply means a resistance is significant, a resistance is not negligible. So which statement is correct? Now, if we look at all these options, we only need to consider horizontal velocity. Horizontal velocity, you see horizontal velocity, and also horizontal velocity, and also we also need to look at time. So these two things we need to understand. We need to be smart to answer this question. So let's try to answer now. So the first case is if there is no air resistance. So let's say this is the tower. As you can see here, this is the tower, and we throw this ball from this tower horizontally, and this ball will go somewhat like this. So this is when there is no air resistance. So if we consider a resistance, so let me redraw this one, the same tower, the same height, the same ball, and the same initial velocity. So here it has initial velocity v, and also here in this case it has initial horizontal velocity v. So in this case, if we consider the effects of air resistance, so these are air particles, simply you can see these are air particles present here, air particles present. So when this ball is moving, let's say the ball is at this point, so this ball will hit air particles. Let's say there is a one particle, air particle is here. So because it has horizontal component of velocity, it will push this particle to the right. Let's say it pushed this particle with force F. So this particle will push ball to the left with the same force F. Okay, so in this case, simply we understand the ball will decelerate. So we will say the ball will decelerate. So we will say the ball will decelerate horizontally. So ball will decelerate horizontally, meaning its horizontal velocity will decrease. So in this case, horizontal component of velocity will not change. So at this point, again, the horizontal component of velocity, that will be equal to v if there is no air resistance. There is no air resistance. So in this case, as we are considering air resistance, so it will go somewhat like this. So at this point, the horizontal component of velocity will be smaller than v. So let's say this is v prime. So v prime will be less than v. So this is one thing we can simply understand. Now the second part we have to look at is time taken. So now in this case there is no air resistance, so the only force acting on the ball is mg, and this is also the net force. We can simply say this is F net, and as it is in free fall, so a will be equal to g, meaning the velocity will change by g after every second. Now, in this case, there is a resistance, so the force acting down, that still is mg. g, but there will be force acting up as well, so that force is a resistance. So in this case, F net will be less than mg. So it will be less than mg, and also we can say A will be less than g. So in this case, it took time t seconds. So in this case, let's say it took time 1. So we can understand t1 has to be greater than t. So this is, if we have this understanding now, simply we will say the horizontal component of velocity will be smaller than initial horizontal component of velocity, means the final one will be smaller than initial, and the time taken will be long. So now we can see the horizontal velocity less than v. So this is according to this one, so that, and more than t also according to this. So it means this is quite reasonable option. Now next one, less than v, that's okay, this is correct. But after t, no, this is simply telling you the t is equal to t1, so this is not correct. So next one, horizontal velocity v, no, it has to be less than. More than t, that's correct. So with velocity, horizontal velocity same is telling you is not changing. Actually horizontal velocity will decrease after time t second, means the time is also the same. So that is wrong, time will be longer. So our answer for this question is, so this is how we can find out answer. Or simply we need to understand is, if there is no A resistance, the horizontal component of velocity will not change. Here is our next question now. It is also based on the same concept. So first thing we need to understand is what is given to us. So in this question, it is given to us a stone is thrown horizontally from the top of a cliff and it falls into the sea after some. A resistance is negligible. So this is very important. When we read questions about kinematics, we need to check carefully, is the A resistance negligible or not. So let's try to answer this question now. As it is given to us, there is no A resistance. So we can also sketch this one first of all. Let's try to sketch. So this is the stone thrown horizontally from the top of a cliff. So it is projected horizontally. So it will go like this. Yeah. Now if we consider this point now, or we take any point, the horizontal, let's say its initial velocity is equal to v, and let's say this is equal to v at, because its initial vertical velocity is 0. So at any point it will be vh, it will not change. Why? Because there is no force acting along horizontal. So it means the horizontal component of velocity will stay same, or we can say vh is constant, or we can also say it will stay same, or you can say stays same. And vertical component will increase. Vertical component will increase. So we need to understand will increase because there is a force acting along vertical. V will increase. Why? Because there is gravity that is acting downwards. And also we can also write down, in this case A will be equal to G because there is no air resistance. So now this is what we need to understand. If we are very clear about this one, then we can simply answer. The first thing has to be horizontal component has to stay same. So if we look at option A, it is telling you as the vertical component is increasing, horizontal is also increasing. So it means this is not good option to choose. Now if we look at B is also telling you as the vertical component of velocity is increasing, horizontal is also increasing. So this is also not a good option. So next one is telling vertical component stays same as horizontal component is increasing, is absolutely wrong. Now let's look at option D now. So what this one is telling us, if we look at horizontal component, you can see here it is not changing, but vertical component of velocity is increasing. So this is what we have already said, and it is according to these concepts. Okay, so it means the best possible answer for this question is D, and this is how we can find out. So here is our answer. Here is our third question. So first of all, let's try to understand what is given to us. So in this question, it is given a stone is dropped from a tall building and air resistance is significant, means we cannot ignore air resistance. And also the variation of distance with time is also shown by dashed line, means here this is. And there is second stone is also dropped from the same building with same dimensions but smaller mass, and from the same building simply means same height. So let's try to answer now how we can answer this. So first of all, we can sketch, let's say here is stone 1, means the first stone. As this stone is dropped, we can say its initial velocity is equal to 0. So this is our stone 1. I can say stone 1. So we need to understand at the beginning the force only acting on this stone will be equal to mg. Let's say this is m1g. So it also means that at the beginning A will be equal to G. But finally, as we can see here, from this point to this point, if we look at this one, this is a straight line. This is a straight line. So it means its gradient is constant. If the gradient is constant, it simply means the velocity is constant, because the gradient of dt graph is equal to velocity. So we can simply conclude from here that velocity is constant. So velocity is constant. So, and this velocity actually is the final constant velocity, maximum constant velocity, and this is called terminal velocity. We can say this is VT1 because we are talking about first stone. Now, when it will reach terminal velocity, at that point we need to understand the force acting down. So that force is equal to mg. So this is m1g. And the force acting upwards, so the force acting up, this force is F air. So at that point, at that time, these two forces are equal. So mean the stone will fall with constant velocity, and that constant velocity we have said is VT1. But let's try to understand second stone now. The second stone has the same dimensions. It has the same dimensions, and but its mass is less. So its mass is m2g. We can say mass is m2g. So it is also dropped. So the u is equal to 0. And at this point, the net force acting on the stone is mg, is the weight. So we can say A is equal to g. So then this stone will reach terminal velocity again. So this stone will also reach terminal velocity. So again, we can say that m2g will be balanced by air resistance, will be balanced by F air. These two forces will be equal. We will ignore upthrust. So these two forces will be equal. So we will simply say at this point the stone has reached terminal velocity. We can say this is VT2. Now the concept we need to understand: smaller mass. If mass is smaller, it means the weight is smaller. If the weight is smaller, it means the air resistance required to balance weight also has to be less. And air resistance, if F air, for example, is less, F air is less, air is less, it means the velocity is also small. Velocity is also small. So it means velocity is also small. And a resistance, as we have at terminal velocity at Vt, we are talking of at Vt when it has reached terminal velocity. So as mg, if the mg is less, so a resistance will be less, will be small, and velocity also will be small. It means the second stone Vt2. So we can also say that, let me change color, so we can say that Vt2 has to be smaller than Vt1. So this is very important point we need to understand. So one thing we need to understand, stone has to accelerate and finally it will reach terminal velocity, and the terminal velocity 2 will be smaller than terminal velocity 1. So now let's try to find our answer. So the answer can be C or answer can be D, because terminal velocity has to be smaller than terminal velocity of stone 1. Vt2 has to be smaller than Vt1. So answer can be C or answer can be D. So first of all, if we look at the D, its gradient is constant. Gradient is constant. So the gradient of this line, gradient is constant. So it's simply telling us it has constant velocity. Constant velocity. So constant velocity. But this is not possible answer, because at the beginning it will accelerate and its initial velocity is equal to 0, but this is telling us it just has constant velocity. So this is not good option to choose. It's a wrong one. And if you look at C now, we can see at the beginning it is accelerating, and after its velocity become, so this is like this, you can see a little more clear. So this is how it is accelerating here. So after that the velocity become constant. So this is our right answer. Here is our last question now. Let's try to understand what is given to us and what we need to find. For this question, it is given to us a car is traveling at constant velocity, as you can see here. Brakes are applied and car decelerate at uniform rate. So what we need to find? We need to find the variation of distance with velocity. So as you can see, on y-axis velocity is given, on x-axis distance is. So but I have seen many students, when they see this question, they just choose option B. Why they choose option B? Because they are familiar with velocity versus time graph for this situation, so they just choose B, because they don't read x-axis carefully. So in this case, x-axis is not time. So now let's try to answer now. How we can answer? So the answer is not B. So first of all, let's get velocity against time. So velocity is on y-axis and the time is on x-axis. This is time. So as the velocity is constant at the beginning, so this is constant velocity, then it decreases at uniform rate. Mean the gradient of this line has to be constant. So this is the case. Now we can take some points on this one. Let's say velocity decreased by this amount, delta V. Let's try to keep same. So this is also delta V. So if we sketch these lines, we can see here, here, and this one is. Okay, we need to understand what area under VT graph give us. Area under VT graph simply is equal to area under VT graph is equal to displacement, or we can say distance, if the body is just moving in a straight line and in one direction. So displacement, or we can say, is distance. So in this case, area under this VT graph is equal to distance or displacement. Okay, now as you can see here now, this area, for example, this one, this is the area, this is area, and then this is second area, this is second one, and this is third area. So we can simply see from here at the beginning, same delta V, for same delta V, there is larger displacement, larger distance, larger displacement means the area under VT graph is greater. So larger displacement at the end, for example, means this part, the last part, and at the end for same delta V means delta V is the same, is shorter displacement, mean distance covered is shorter, or we can simply say shorter displacement. So this is the main concept we need to understand. Means for the same change in velocity at the beginning, displacement is larger. At the end, for the same delta V, displacement is shorter. So now we can go and we can find our answer. So this is 100%, this is not possible answer. And this one we have already said, this is also not possible. So the answer can be A, or answer can be C. So let's try to find out now. For same delta V, we can find out here. So for same delta V, so let me give you kind of feelings about that so you can see what actually is happening. For the same delta V, what I'm saying same delta V, it means this delta V here, this delta V are the same. So we can draw also vertical lines. So this is S, and if you look at the next one, this is the S, and if you look at the next one, this is the S. So in this case, you can see it is very clear that with delta V, S is decreasing. So this is the S. So this is the S is decreasing. So at the beginning, it is this, then smaller and smaller. It's very clear to see this one, and this is what we have found. So this is our answer. If we check C, we will not get the same thing. So let me little explain to you if you are curious about this one. Let's see same delta V. Let's say for this delta V, okay, so we can see here. Okay, so this is not very clear to see. Let me redraw this one so you can see better. So this is telling us at the beginning delta S is small, but at the end delta S is greater, mean distance is larger. This is just opposite. So this is not possible answer. So our answer is A.